In the process of learning taking square roots and how it works, I'm going to look at problem 28 on page 167. At any point in time, if you fall behind, if you have questions, you know what to do. Unmute yourselves and say anything. Equals -7. We know something very important, and that's a note. If I have a square root or any even, I have here an even number, the square root or the fourth root or the sixth root, etc., an even number, the quantity under the square root has to be positive or 0. Always. So that's number one. Number two, if the radical has an odd index, like the cube root, the seventh root, whatever, it does not matter. Anything goes. So this is the one I call friendly. This is the one I call not friendly. What happens as the third note? What happens if I take a square root or an even root, the fourth or the sixth root of a negative number? This is not a real number. Not a real number. So obviously coming back, so please keep this note in mind, because we're going to use this idea, this concept a lot when we talk about radical functions, square root. Very important note. So even index, not friendly. Requires positive or 0. Odd index, anything goes. When the index is even and applied to a negative number, the answer is not real. You may remember from your past math classes that the square root of -1 is called the imaginary unit. And it is denoted by I. Also, when you square both sides, I squared equals -1. This cannot happen with a real number. Any number you square, if it's a real number, you can never get -1. So two things we need to remember, that I squared is -1 and the square root of -1 is I. This comes from complex or imaginary numbers. Please remember this, and please remember this. Okay, so finally, after all this review, I can go back and solve that equation. Okay, so let's write it. Okay, so I'm going to copy it again. I don't want to start there and continue here. You don't have to copy it unless you want to. So why do I apply the square root? Because the setup is something squared with a variable in it equals a number. Every time I see this setup, I think of taking the square root. Very convenient. But remember, I should write the answer as the absolute value of x plus 2. I will not, because instead of that, I put plus or minus on the other side. Now I'm having some difficulty with this because I know this is not a real number. So let's take it on the side. And I know that the square root of -7 can be rewritten as the square root of -1 multiplied by the square root of 7. Because this can be rewritten as -1 times 7. But I already refreshed my memory on this. What does it mean? Well, it's I. And now I go back and I write I the square root of 7. Is it done? Almost. All I have to do is subtract 2 from both sides. But I have to put it in front of plus or minus. I cannot separate these. These are one unit together. So then x equals -2 plus or minus I the square root of 7. Questions from me or I continue? Any questions? Any questions? Any questions? Okay. Is anyone paying attention? Anyone there for me?
I'm here.
Okay. Good. I'm going to select another problem, like let's say 24, same page, and then we'll continue unless you need more examples. Same idea. On 24 we have 3. X plus 4 squared equals 21. Okay. Remember, when I look at this equation, I'll say, oh, I take the square root. Yes, but it's not completely simplified yet. I want to simplify if I can. Here, there was nothing I could do to simplify. Nothing. But here I can simplify. What am I referring to? How can I simplify this?
You can divide both sides by 3.
Excellent job. Absolutely. Clean it up if you can. So this divided by 3 is x plus 4 squared. And this divided by 3, because I have to divide both sides, is 7. Now everything is nice and clear. I can take the square root. I have to be clear. Obviously it's quadratic. I expect 2 solutions. So instead of writing the x plus 4 in absolute value, from here I will write x plus 4. Instead of the absolute value, I put plus or minus. Since I cannot apply the square root to 7, it has to stay as is. The only thing I have, move 4. And it's done.
Sorry, I didn't see what happened to the 3 at the beginning of the question.
3 x plus 4 squared divided by 3 is x plus 4 squared. 21 divided by 3 is 7.
Oh, okay.
Is that okay, everyone?
Makes sense.
Perfect. Do we think that we can move on? We think we can move on to completing the square now?
Yes.
So this is method 3. So for now, we know 2 methods. And the question is, when do I use this one? It's very clear. Only in a very specific situation. When I have a square completed with x and a number on the other side. The method cannot be applied otherwise. When do I apply the first method, which is factoring? Only if I can factor. And only if I can factor quickly. Because I don't want to spend my time on factoring if I can use something else faster. So factoring, if it's factorable and if it doesn't take a lot of time. When do I use this? In a very specific situation, one time, only when it's set up like that. When do I use complete the square? Never. Unless you force me to. I will never use complete the square to solve a quadratic equation. Ever. However, why is this method here? It's because it's possible. It alone will not do the job. And the obvious question is, then why? For something else that is in chapter 2. So basically this is for a topic in chapter 2. And then why do we need to study it here? Because it works. Very cumbersome, not doing the job alone by itself, but it works and we study it now. But it's used for something else. Okay, so what is the idea behind completing the square? So I'm just going to directly go through an example and explain. So we have many questions here, 47 through 64 on page 167. I'm going to write that down for you. I'm going to start with, let's say, with 50. 167. So this is x squared plus 4x equals 12. Coming back to this. I know you're going to get sick and tired of this handout. See, there are three terms here. Why did I choose the first one? Because I see plus here. I'm going to copy this down so we have it in front of us. So I'm thinking of a plus b everything squared, which we know is a squared plus 2ab and plus b squared. And I see that this piece can be considered a squared. And I'm hoping that I can find this to be this, but I need a third term, which I don't have. If I had in here this third term, which I don't have and I have to determine, then these three terms will be written like this. Okay? So I know that I have to add a term, but I have to add it to both sides. Otherwise, I change the problem. And once I add the same term to both sides, then this will change into x plus, I'm not sure yet what, squared, equals this number, the sum of these two. Okay, how do I determine that number? It's a 4-step procedure to determine this number and complete the square. Okay, ready? First step procedure, first in the 4-step procedure is identify the middle coefficient. Okay, fine, I identified it. It's positive 4. Careful, because this expression has to be in descending order. If it's not in descending order, I will make a mistake on identifying the middle coefficient. Okay, next step, step 2. Divide it by 2. Okay, 4 divided by 2 is 2. And let's stop for a moment. Why do I need to divide it by 2? It's because of this. I divide by this number to get the second coefficient, the second term. Once I divide by this number, I will discover this term. Okay, so I got 2. In step 3, I have to square this number, the result from 2. The result from 2, this number, squared is 4. And step 4, add 4 to both sides. And complete the square. So first step, identify the middle coefficient. Step 2, divide it by 2. Why 2 and not 5 and not 10? Because of this coefficient. I'm dividing by it. I square the result. I get 4. And then add 4 to both sides. Now, I'm coming back. Let me give you a second to write this down. Now I'm coming back and I put the 4 where it belongs. This 4 that I need to add to both sides. So then I'll copy the equation here on this page. So then I have x squared plus 4x plus 4. Obviously it's 12 plus 4, which is 16. But now, that's why I insisted on this from the very beginning. I need to determine this. a squared plus 4x plus 4. A squared plus 4x plus 4, what does it equal to? Can anyone complete the square for this, for us? That's why I wanted you to work on the factoring so we don't have difficulties now.
X plus 2.
Great job, thank you very much. Okay, I'm done completing the square. So, as I mentioned before, it cannot do the job. I have to go back to this procedure from before. Method 2, I can solve. If I don't remember that now, if you expand, you're going backwards, right? So once I completed the square, that's fine. Okay, so I get x plus 2. I should put the absolute value. Instead, I write plus or minus 4. Of course, I expect two solutions because it's quadratic. I will move 2 like before, but now I have to separate them. In the previous example, there was no point in separating them. I can simplify. Even if I write negative 4 plus, negative 4 minus, which my lab math will ask you to though, with a comma between the two of them, they don't have the symbol plus or minus. But in writing, there is no need because I can simplify them, but now I have to. Negative 2 plus 4, that's the first solution, and negative 2 minus 4, that's the second solution. And this is how the method of completing the square.
So in this, completing the square would just be like an extra step to get you to a place where you can use another
Yes, yes, because it alone cannot do the job. Again, I'm saying, when will I ever use this method to solve quadratic equations? Never. But if you force me to, I have no choice. But the method is used for something else. This is a super cumbersome method, but it's used for something else. It works, if you want, partially, because it alone cannot do the job. But yes, I agree with your comment completely. Absolutely. That's another way of thinking about quadratic equations. Let's look at another example. So let's say 54. Same page, 167. Let me see with the time. So let me